Hi, Namaste. This is Girish from Alva PU College, Department of Chemistry. Today's topic is S-block elements and hydrogen. Okay, first question. 100 ml of a water sample contains 0.81 gram of calcium bicarbonate and 0.73 gram of magnesium bicarbonate. The hardness of this water sample expressed in terms of equivalents of calcium carbonate is. So the given values are molar mass of calcium bicarbonate 162, magnesium bicarbonate 146 and calcium carbonate molecular mass is 100. Okay. So in this case they are given in the 100 ml of water 0.81 gram of calcium bicarbonate is present and 0.73 gram of magnesium bicarbonate is present. So we have to express these two values with refers to the equivalent mass of calcium carbonate. Okay. So now when we come to the ppm of the calcium carbonate, the ppm parts per million of calcium carbonate is equal to 0.73 by 146, means 0.73 is the mass of magnesium bicarbonate and its molecular mass is 146 plus 0.81 gram, that is the mass of the calcium bicarbonate divided by 162 molecular mass into 100. This 100 is so for 100 gram of the calcium carbonate, okay, and this 100 is 100 ml, means mass divided by volume of a solution into 10 to the power of 6. If you simplify this, you will get 10 to the power of 4, means option must be first option. Okay, second question. For two ionic solids, calcium oxide and potassium iodide, which of the following statements is false? So we have to identify the wrong statements. See, it's very simple. Two ionic solids, that is calcium oxide and potassium iodide. These two are ionic compounds. When you look up at the option, potassium iodide is soluble in benzene. It's a wrong concept because potassium iodide is an ionic compound, hence it is insoluble in benzene, hence option must be fourth one. Let us go for the third question. A metal M readily forms its sulphate, MsO4, which is water soluble. It forms its oxide MO, which becomes inert on heating. It forms an insoluble hydroxide MOH twice, which is soluble in sodium hydroxide solution. Then M is. So they are given the clues that a metal readily forms a sulphate, that is water soluble sulphate. And second thing is its oxide is inert to the heat. And third concept is it forms an insoluble hydroxide MOH twice, but this MOH twice is soluble in sodium hydroxide solution, means the option must be a metal beryllium forms a water soluble sulphate and it forms the inert BeO on heating and its hydroxides is soluble in sodium hydroxide solution. So option must be fourth one. Let us go for the fourth question. Which of the following sequences represents the increasing order of the polarizing power of the cationic species? K plus, Ca2 plus, Mg2 plus, Be2 plus. See, they are asking about the increasing order of the polarizing power of the cationic species. Polarizing power is the charge by size ratio. Okay, it is a charge by size ratio. Okay, if the charge is more, size is less, obviously the polarizing power is more. So among these, the smallest one is beryllium and its charge is more, hence its polarizing power is more. So therefore, potassium, it is lesser polarizing power than calcium, than magnesium, than beryllium, hence the option must be fourth one. Okay, let us go for the fifth question. Which of the following has the correct combination considering the column 1 and column 2? Means we have to go for the match the following concept like this. Okay, see BeH2, SiH4, LiH3, LiAlH4 here, and here they are given complex, interstitial, covalent and polymeric. See, BeH2, beryllium hydride, is polymeric in nature, means P must be fourth one, but they are given P2, they are given, it is not the correct option. SiH4 is a covalent compound, means it has Q3, but Q they are given 4, it is not a correct option. LiH3 LaH3 is an interstitial compound, means R has to become 2, but they are given 3. It is not a correct thing. LiAlH4, lithium aluminum hydride. Lithium aluminum hydride is a complex, first option. So fourth one they are given correct combination, hence the option must be fourth one. Let's go for the sixth question. What is formed when calcium carbide reacts with heavy water? It's very simple. When calcium carbide reacts with heavy water, that is D2O, it forms C2D2, like C2H2, okay, and calcium hydroxide. Hence the option must be first one. Okay, let us go for the seventh question. Chemical A is used for the water softening to remove temporary hardness. A reacts with sodium carbonate to generate the caustic soda. When carbon dioxide is bubbled through a solution of A, it turns cloudy. What is the chemical formula of A? See, they are given some clues. We have to make use those clues. See, chemical A is used for the water softening to remove the temporary hardness. So generally among these, to remove the temporary hardness of water, calcium hydroxide is used. Okay. And the second thing, A reacts with sodium carbonate to generate caustic soda. Okay. When carbon dioxide is bubbled through a solution of A, it turns cloudy. Calcium hydroxide is also called as the lime water. When carbon dioxide is passed through lime water, it turns milky. See, when carbon dioxide reacts with calcium hydroxide, it gives calcium carbonate. It is a cloudiness, okay. It gives turbidity. Hence, option must be third option. Let us go for the eighth question. 2 moles of aluminum is treated separately with excess of dilute sulfuric acid and excess of sodium hydroxide. The ratio of volume of hydrogen evolved under similar conditions of pressure and temperature is. So the thing is, 2 moles of aluminum is treated with dilute sulfuric acid and 2 moles of aluminum is treated with sodium hydroxide. See, let us go for the chemical reaction. When aluminum is treated with sulfuric acid, you will get aluminum sulphate and hydrogen gas. And meanwhile, when aluminum is treated with sodium hydroxide in the dilute media, you will get sodium aluminate and hydrogen gas. When you balance these two reactions, you will get the 3 hydrogen gas here and 3 hydrogen gas here. Means 3:3, the ratio is 1:1 ratio. Hence option must be second one. For the ninth question, reaction between following pairs will produce hydrogen except copper reacts with HCl, Fe plus H2SO4, Mg plus steam, Na plus alcohol. See, among these, the very simple concept is the first option, because copper cannot displace hydrogen from dilute HCl, because copper E0 value is greater than the hydrogen, hence copper cannot displace the hydrogen, hence option is the first one. Now let us go for the 10th question. The correct order of increasing ionic character. So they are given BeCl2, MgCl2, CaCl2 and BaCl2. Be, Mg, Ca and Ba. These are the second group elements in the periodic table. Obviously we know that down the group, ionic character increases or metallic character increases. So if the metallic character increases, means obviously ionic character also increases. So Be, Mg, Ca, Ba. So this is the correct option. Okay, first one is the correct. Okay, now 11th question. The oxidation state of oxygen atom in potassium superoxide is. Potassium superoxide means KO2. So now you calculate the oxidation state of oxygen. Potassium plus 1, oxygen we don't know, let us take it as X, and there are 2 oxygen atom is equal to 2 and X is equal to 1 by 2, minus 1 by 2. Hence option is second option. In which of the following species the size of the first species is not more than the second? Means they are given the 2 ions, okay, Na plus F minus. Among these two we have to identify the first one must be smaller in size than the second one. See, when you look over the first option here, Na plus and F minus, these two are the isoelectronic species. Means they have the same number of electrons, okay. In the isoelectronic species, the cationic size is always smaller than the anionic species. Okay, means Na plus is smaller one, F minus is bigger one, hence the option is the first one. Let's go for the 13th question. Select the correct statement. Blue solution of sodium in liquid ammonia is unstable with respect to amide formation. See, this is correct actually, because when metal reacts with liquid ammonia, it forms a metal amide and ammoniated electron. So because of the presence of metal amide, it is unstable. Na2O2 reacts with CO and evolves oxygen. See, Na2O2, when it reacts with carbon monoxide, it produces sodium carbonate, but there is no evolution of oxygen. Hence, this statement is wrong. Third one, Li plus does not form alum due to its high hydration energy. See, Li plus does not form alum, that is correct, but not because of high hydration energy, that is because of the small size of the Li plus, okay. NaNO3, when heated at 800 degrees Celsius, produces two gases, both are paramagnetic. See, that this concept, when NaNO3, when it is subjected to heat, it produces NaNO2 plus half O2. When NaNO2 undergo further decomposition to produce NaO and N2 plus half O2, means it produces two types of gases. One is oxygen and the other one is nitrogen. But nitrogen is diamagnetic in nature, oxygen is paramagnetic in nature. Hence the fourth statement is also wrong. Hence the first option is correct. 14th question. 1 mole of magnesium nitride on reacting with an excess of water gives. See, just you write the equation, you will come to know the answer. 1 mole of magnesium nitride, that is Mg3N2, when it reacts with excess of water, gives MgOH twice and 2NH3 when it is balanced. So you will get the 2NH3. Hence option must be 2 moles of ammonia. Third option. 15th question. 1 mole of a mixture of CO and CO2 requires exactly 1 liter solution of 1 molarity NaOH for complete neutralization. If CO present in mixture is now converted to CO2 and again the mixture is treated with NaOH, then after this conversion, moles of CO2 present initially in mixture 1, 2 liter solution of 1 molarity NaOH is required for more neutralization. 40 gram NaOH in aqueous solution is required more for neutralization. 2 liter solution of M/2 NaOH is required more for neutralization. Which are correct? Means we have to identify the correct statement among these 4 statements. Let us go one by one, okay. Moles of CO2 present initially in mixture 1 mole. It is not correct because carbon dioxide and carbon monoxide togetherly it is 1 mole they are given, okay. Means carbon dioxide initially it is not 1 mole, hence it is a wrong statement, okay. Let us see the second option. 2 liter solution of 1 molarity NaOH is required more for neutralization. 2 liter solution of 1 molarity. 1 molarity means 1 mole of a substance. 1 mole of NaOH is present. 1 mole means 40 gram. 2 liters of 1 molarity means 40 into 2. Totally it becomes 80 gram. Okay, but actually when you look about the chemical equation, when NaOH is treated with half CO2, half Na2CO3 plus half H2O, means 40 gram of NaOH is required to neutralize half mole of CO2. Means 40 gram is required, not the 80 gram, okay. Means the second statement is also wrong. Let us see the third option. 40 gram of NaOH in aqueous solution is required more for neutralization. That is correct, because 40 gram is required for neutralization of half CO2, half moles of CO2. So this is correct option, okay. Let us see the fourth option. 2 liter solution of M/2 sodium hydroxide is required more for neutralization. See, 2 liter solution of M/2 sodium hydroxide means 2 liters of 1 M/2 sodium hydroxide. 1/2 M sodium hydroxide is equal to 2 liters. So number of moles is equal to molarity into volume. So molarity is given, that is 1/2 molarity. 1/2 into volume is 2 liter, hence it is 1 mole. Means 2 liter solution of M/2 sodium hydroxide also contain 1 mole of NaOH, hence this is also correct. Means these two are the correct statement and A and B are the wrong statement, hence we have to go for the option 4th one. 16th one, the correct statements are: the saline hydrides produce hydrogen gas when reacts with H2O. Saline hydride means NaH. When it is treated with water, it gives sodium hydroxide NaOH plus H2 hydrogen gas. So the statement is correct, because saline hydride produces hydrogen gas when it is treated with water. That is a correct concept. Okay. Reaction of lithium aluminum hydride with BF3 leads to B2H6. So this is also correct. Okay. When lithium aluminum hydride reacts with BF3 produces B2H6. So statement is correct. PH3 and CH4 are electron rich and electron precise hydrides respectively. That is also correct. See, PH3 in P, it has one lone pair of electron and 3 unpaired electrons, and 3 unpaired electrons makes the bond with 3 hydrogen, means due to presence of lone pair of electron, it is an electron rich group. Okay. Carbon in CH4, it has 4 valence electrons, hence electron precise. So statement is correct. Fourth one, HF and CH4 are called as molecular hydrates. That is also correct. Okay. Means all the 4 options are correct. Hence we have to go for the first option. Question number 17. On heating, which of the following releases CO2 most easily? Means MgCO3, K2CO3, CaCO3, Na2CO3. Among these, which one is the least stable on heating? So that is the thing we have to look about it. Okay. See, when you look about these options, thermal stability order increases down the group. Means from magnesium, calcium, when you go down the group, the thermal stability increases for the carbonates. Means the least stable one is magnesium carbonate, hence it gives out the carbon dioxide very easily. Hence the option is first option. Now 18th question. The alkaline earth metal nitrate that does not crystallize with water molecule is. See, we know that formation of crystal with water decreases down the group. Means the barium, it comes at the bottom. Hence barium nitrate do not forms the crystal easily with water. Okay. Hence the option must be first option. 19th question. When X subjected to heat, it produces a residue plus colorless gas. When that residue is treated with water, it gives Y, and that Y, when it is treated with excess of carbon dioxide, it gives Z. When Z once again subjected to heat, it gives X. So we have to identify X, Y and Z. See, they are given the different compounds here. A very simple concept is, when calcium carbonate, when it is subjected to heat, it produces CO, CaO and CO2. Carbon dioxide is a colorless gas. So when this is treated with water, CaO is treated with water, you will get calcium hydroxide. When calcium hydroxide is treated with excess of carbon dioxide, produces calcium bicarbonate. Okay. When calcium bicarbonate is subjected to heat, it produces calcium carbonate. Hence the X is calcium carbonate and the Y is CaOH twice, and the Z is this one, calcium bicarbonate. So option must be second option. 20th question. The oxide which is paramagnetic in nature is Na2O2, CSO2, Na2O, O3. It's very simple. All the superoxides are paramagnetic in nature due to presence of unpaired electrons. So among these, the superoxide is cesium superoxide. Okay. Hence it is a paramagnetic in nature. Hence the option is second option. Let's go for the 21st question. The bond angle and the dipole moment of water molecule, water respectively, are. Very simple. The bond angle and dipole moment for the water molecule is 104.5 degree and 1.84 dipole. The option is third option. Number 22. The method used to remove the temporary hardness of water is. The method which is used to remove the temporary hardness of water is Clark's method by using calcium hydroxide. Hence option is third option. 23rd question. Microcosmic salt on heating gives. See, microcosmic salt means a salt which is present in urine. Okay. So when that microcosmic salt, it's formalized this one, NaNH4 HPO4.4H2O. When it is subjected to heat, it produces NaPO3, NH3 and 5H2O. Hence option must be first option. Number 24th. Which of the following pairs are chemically dissimilar? Which of the following pairs are chemically dissimilar? See, Na and K both belongs to the S group elements, S block elements. They have the same chemical properties. B and S are, they belongs to the same group. Zr and HF, they belongs to the D block elements. Ca and Zn, whereas Ca belongs to the S block, Zn belongs to the D block, hence they have dissimilar properties, hence option is fourth option. Let's look about the 25th question. The pair in which both the species are used in the preparation of antacids is antacid. See, used in the preparation of antacid is sodium bicarbonate and magnesium hydroxide. So first option is correct. Let us see the 26th question. Two metals X and Y belongs to the second group of periodic table. X forms insoluble oxide but soluble sulphate, Y forms soluble oxide but insoluble sulphate. Hydroxides of metal X is soluble in NaOH while that of metal Y is insoluble in sodium hydroxide. What are metal X and Y? So they are given the different clues here. So we have to identify the metal X and metal Y. See, among two metals X and Y, they belongs to the second group elements in the periodic table. X forms insoluble oxide. X, if it is forms the oxide, it is insoluble in water. Okay, it is insoluble in water. See, when you come to the BeO, it is insoluble. BaO is soluble in water. BeSO4, beryllium sulphate, is soluble, whereas BaSO4 is insoluble in water. BeOH twice, beryllium hydroxide, it is soluble in sodium hydroxide, but BaOH twice is insoluble in sodium hydroxide. Then X must be Be and Y must be Ba, means option must be first one. Yeah. Question number 27. See, when you look about the assertion, ortho and para hydrogen are nuclear spin isomers. Reason, they have same nuclear spins. Now first let us look about ortho and para hydrogen means what. See, ortho and para hydrogens, they differ in the spinning up of protons which is present in the nucleus, means nuclear spin. That is correct option. Okay, ortho and para hydrogens are nuclear spin isomers. In ortho hydrogen, the spinning up of protons are in the same direction, whereas in para hydrogen, the spinning up of protons in the nucleus are in the opposite direction. Okay, so the statement, the assertion is correct. When you come to the reason, they have same nuclear spins. It is wrong actually. Same nuclear spin is not there. Okay, ortho, they have the same, whereas para, they do not have the same nuclear spin. Hence, we can go for the option, that is third one. Assertion is true, but the reason is false. Let's go for the 28th question. The order in which the following oxides are arranged according to a decreasing basic nature is decreasing basic nature. Na2O, MgO, Al2O3, CuO. S block, first group elements, second group elements, P block and the D block elements. Okay. See, among these, across the, if you move across the period, the basic character decreases and down the group basic character increases. So by looking about this concept, we can go for the first option. Na2O is more basic in nature than MgO, than Al2O3, than CuO. Option must be first option. Now let's go for the 29th question. Among NH3, H2O, HF and H2S, which would have highest magnitude of hydrogen bonding? Highest magnitude of hydrogen bonding. Hydrogen bonding is depending on electronegativity. So highest electronegativity is exhibited by fluorine. Hence hydrogen fluoride can make the strong hydrogen bond. Okay, hence the option must be first option. Question number 30. Which of the following has the correct combination considering column 1 and column 2? See, column 1, CaCO3, sodium thiosulfate. Sodium thiosulfate is also called as hyposolution. Sodium nitrate, NaNO3. Sodium bicarbonate, NaHCO3. See, so calcium carbonate is used as a flux in metallurgy, that is in the extraction of iron. Sodium thiosulfate, that is hyposolution, it is used in black and white photography. Sodium nitrate, it is used in gunpowder, whereas sodium bicarbonate, it is used in the fire extinguisher. Means we can go for the option second. Number 31, in which of the following reactions H2O2 acts as a reducing agent? So they are given the 4 option here. So we have to identify the H2O2 is acting as a reducing agent. See, very simple. H2O2 plus 2H plus 2 electron, addition of 2 electron here. H2O2 plus minus 2 electron, H2O2 plus 2 electron, H2O2 plus 2OH minus 2 electron. Loss of electrons takes place in option number 2 and option number 4. In these two cases, hydrogen peroxide acting as a reducing agent, hence option must be first one. Question number 32, syngas is a mixture of syngas or synthetic gas. It is a mixture of carbon monoxide and hydrogen gas, hence the option must be 2. Question number 33, the deep color produced when iodine is dissolved in a solution of potassium iodide is caused by the presence of, means when the iodine is dissolved in potassium iodide is treated with iodine, you will get the Ki3. Ki3 is deep blue in color. Ki3, if you write the ionic condition, it will become I3 minus, hence option is 3. Question number 34, the lattice energies of the following have the order. See, they are given Ba, Sr, Ca and Mg. We have to identify the lattice energy. Lattice energy is depending on the size of the cation. Smaller the size of the cation, stronger the ionic lattice. Among Ba, Sr, Ca and Mg, smaller one is Mg than Ca, than Sr, than Ba. Means the first option is correct. Lattice energy of BaO is lesser than SRO, than CaO, than MgO. Hence the first option is correct. Question number 35. Which of the following statements about alkaline earth metals are correct? Hydration energy of Sr2 plus is greater than that of Be2 plus. It is wrong because Sr2 plus is bigger in size than Be2 plus. Hence hydration energy of Be2 plus is greater than Sr2 plus. Hence the first statement is wrong. When you come to the second one, CaCO3 decomposes at higher temperature than BaCO3. This is also wrong because CaCO3 is less stable than BaCO3. Hence it decomposes easily than BaCO3. Hence the second statement is also wrong. When you come to the third statement, BaOH twice is stronger base than MgOH twice. It is correct because Ba is bigger in size than Mg, hence ionic character is more for this. It's a stronger base than MgOH. So third statement is correct. When you come to the fourth statement, SrSO4 is less soluble in water than CsSO4. It is also correct. SrSO4 actually it is insoluble in water, but CsSO4 is soluble in water. Hence the third and fourth options are correct. Hence we can go for the fourth option. Question number 36. On heating a mixture containing 1 mole each of Li2CO3 and K2CO3 will produce, means when you heat Li2CO3 and K2CO3, a carbon dioxide gas is released. But the thing is, among Li2CO3 and K2CO3, Li2CO3 undergo for decomposition to produce Li2O and CO2. But K2CO3 is thermally stable. Hence, it cannot produce the carbon dioxide gas. Okay. Hence, Li2CO3 produces 1 mole of carbon dioxide gas. Hence, option must be second one. Question number 37. Strongest reducing agent in the aqueous solution is Na, Rb, Ca and Li. Obviously, it is very simple. Lithium is the strongest reducing agent. Option is fourth one. Let's go for the 38th question. A metal M reacts with N2 to give a compound A, M3N, and A on heating at high temperature gives back M, and A on reacting with H2O gives a gas B. B intensifies color of copper sulphate solution when passes through it. M and B can be. See, we have to identify the M and B now. A metal M reacts with N2. It produces M3N. M3N means the compound here they are given Mg, Na, lithium and aluminum. M3N compound can be given only by lithium and the sodium. But if you consider the lithium reacts with nitrogen to form Li3N. Now you consider this is A. When A is treated with water, it gives LiOH and NH3. NH3 is a gas, so that gas is B. It reacts with water, gives a gas B. Okay, this is the gas B. Okay, when ammonia is treated with water, it gives ammonium hydroxide. When ammonium hydroxide is treated with copper sulphate, it gives a cuprammonium sulphate. It is a deep blue color. Okay, hence we can go for the option third one. Question number 39. Child saltpeter is, it is a common name given to sodium nitrate. So option must be first option. Question number 40. Some large white transparent crystals are left out in a bowl for several days. They are then observed to have changed their form into white powder. The crystalline may have been of, say, initially a white transparent crystals. When it is exposed to the air for a longer time, it becomes a white powder. So means that compound is ammonium chloride, sodium carbonate or calcium carbonate. We have to identify which compound it is. See, actually sodium carbonate is correct. Why the sodium carbonate is correct? Sodium carbonate is always associated with water. Hence, if it is associated with water, it is a crystalline, it is a white transparent crystalline. When it is exposed to air, it is efflorescent actually. When it is exposed to air, it loses water molecule and it becomes white powder. Hence, the option must be sodium carbonate, third option. Question number 41. On reaction with water, which of the following does not produce any hydride? See, when you look up at the four options, you can come to know the answer very easily. On reaction with water, which of the following does not produce any hydride? See, it is already in the hydride form, so it cannot produce further hydride. Hence, option must be third one. Question number 42. Colgan used as water softener is. So among these, which one is the colgan? See, sodium hexametaphosphate. Sodium hexametaphosphate, that is third option. It is also called as colgan. It is used in softening of hard water. Hence the option is third one. Okay, now let's go for the question number 43. A dilute solution of H2O2 is labeled as 20 volume. Its percentage strength is. So H2O2 is labeled as 20 volume. What should be the percentage strength? See, when you come to the volume strength formula is 5.6 into N. That is normality. Now 5.6 you keep like that only. When normality can be expressed as percentage strength into 10 divided by equivalent weight. Now you take the percentage strength to the left side. Percentage strength is equal to 17 into 20 divided by 5.6 into 10. Okay. So that is equal to 6%. Okay. So you will get the second option. Number 44. In acidic medium, H2O2 acts as a reducing agent in its reaction with. See, H2O2 acts as a reducing agent in acidic medium with KMNO4. See, when you look over the equation, when H2O2 reacts with KMNO4, H2SO4 plus K2SO4 plus MnSO4 H2O and O2, hence oxidation number changes from -1 to 0, hence H2O2 acts as a reducing agent in acidic medium with KMNO4. Option must be second one. Question number 45. Hydrogen behaves as an oxidizing agent in its reaction with. Hydrogen behaves as an oxidizing agent. Means hydrogen undergo for reduction. Means it has to accept the electron. See, chlorine, nitrogen, sodium, sulfur. Among these three, sodium is a metal. Metal can donate electron. Hydrogen will accept the electron. Hence, hydrogen undergo for reduction. Hence, the option must be third option. Dear students, you have plenty of time for the preparation for NEET and CET exam. You do well, manage the time. All the best.